Of all our planets, Uranus has had a tough time in the reputation stakes over the years. Its name alone is the butt of jokes, and NASA's recent announcement stated that it wanted to target Uranus with a probe was a comedian's field day. Okay, in this video, let's see how the planet Uranus was discovered, and the reasons that NASA is stating that it wanted to send a probe to the Uranian system. All the inner planets have been known since ancient times because they are easy to spot in the night sky, but Uranus was the first planet to be discovered by telescope, and even then astronomers thought it was a comet or a star. If William Herschel had his way in 1781, our seventh planet would have been called George Sidus, or George's star, after his patron King George III. 70 years later astronomers settled on Uranus. While many people pronounce the planet as Uranus, astronomers prefer to say Uranus. But Uranus is much more regal. It was named after the Greek god of the sky, Uranus, father of Saturn and grandfather of Jupiter. Voyager 2 made its closest approach to Uranus on January 24, 1986, coming within 81,500 kilometers of the planet's cloud tops. This was the probe's first solo planetary flyby, since Voyager 1 ended its tour of the outer planets at Saturn's moon Titan. The length of a day on Uranus as measured by Voyager 2 is 17 hours and 14 minutes. Uranus is distinguished by the fact that it is tipped on its side. Its unusual position is thought to be the result of a collision with a planet-sized body early in the solar system's history. Given its odd orientation, with its polar regions exposed to sunlight or darkness for long periods, and Voyager 2 set to arrive around the time of Uranus's solstice, scientists were not sure what to expect at Uranus. The presence of a magnetic field at Uranus was not known until Voyager 2's arrival. The intensity of the field is roughly comparable to that of Earth's, though it varies much more from point to point because of its large offset from the center of Uranus. The peculiar orientation of the magnetic field suggests that the field is generated at an intermediate depth in the interior where the pressure is high enough for water to become electrically conductive. Voyager 2 found that one of the most striking influences of the sideways position of the planet is its effect on the tail of the magnetic field, which is itself tilted 60 degrees from the planet's axis of rotation. The magnetotail was shown to be twisted by the planet's rotation into a long corkscrew shape behind the planet. A high layer of haze was detected around the sunlit pole, which also was found to radiate large amounts of ultraviolet light, a phenomenon dubbed electroglow. The average temperature of the atmosphere of the planet is about 59 Kelvin. Surprisingly, the illuminated and dark poles, and most of the planet, show nearly the same temperature at the cloud tops. Voyager 2 found 10 new moons, bringing the total number to 15 at the time. Most of the new moons are small, with the largest measuring about 150 kilometers in diameter. The moon Miranda, innermost of the 5 large moons, was revealed to be one of the strangest bodies yet seen in the solar system. Detailed images from Voyager 2's flyby of the moon showed huge oval structures termed coronae, flanked by faults as deep as 20 kilometers, terraced layers, and a mixture of old and young surfaces. In March 2020, NASA astronomers reported the detection of a large atmospheric magnetic bubble, also known as a plasmoid, released into outer space from the planet Uranus, after re-evaluating old data recorded by the Voyager 2 space probe during a flyby of the planet in 1986. The exploration of Uranus has, to date, been through telescopes and a lone probe by NASA's Voyager 2 spacecraft, which made its closest approach to Uranus on January 24, 1986. It also imaged Uranus's 5 large moons, revealing that their surfaces are covered with impact craters and canyons. Despite NASA's announcement, a number of dedicated exploratory missions to Uranus have been proposed, but as of 2022 none have been approved. Okay, let's have a look at those missions. A number of missions to Uranus have been proposed. Scientists from the Mullard Space Science Laboratory in the United Kingdom have proposed the joint NASA-ESA Uranus Pathfinder mission to Uranus. A call for a medium-class mission to the planet to be launched in 2022 was submitted to the ESA in December 2010 with the signatures of 120 scientists from across the globe. The ESA caps the cost of M-class missions at €470 million. In 2009, a team of planetary scientists from NASA's Jet Propulsion Laboratory advanced possible designs for a solar-powered Uranus orbiter. The most favorable launch window for such a probe would have been in August 2018, with arrival at Uranus in September 2030. The science package would have included magnetometers, particle detectors and, possibly, an imaging camera. A mission to Uranus is one of several proposed uses under consideration for the unmanned variant of NASA's Heavy Lift Space Launch System (SLS) currently in development. The SLS would reportedly be capable of launching up to 1.7 metric tons to Uranus. In 2013, it was proposed to use an electric sail (e-sail) to send an atmospheric entry probe to Uranus. In 2015, NASA announced it had begun a feasibility study into the possibility of orbital missions to Uranus and Neptune, within a budget of $2 billion in 2015. MUSE, conceived in 2012 and proposed in 2015, is a European concept for a dedicated mission to the planet Uranus to study its atmosphere, interior, moons, rings, and magnetosphere. It is suggested to be launched with an Ariane 5 rocket in 2026, arriving at Uranus in 2044, and operating until 2050. In 2016, another mission concept was conceived, called Origins and Composition of the Exoplanet Analog Uranus System Oceanus, and it was presented in 2017 as a potential contestant for a future New Frontiers program mission. Future launch windows are available between 2030 and 2034. China plans to send its first exploration mission to Uranus in 2046. But these missions are just a proposal, and as mentioned earlier, none have been approved for developmental stage. With some of the proposals had already lost its launch window opportunities, and with some other missions are nearing its launch window time period, there is a high possibility that one of these proposed missions could get its ride to Uranus in the future. If you are interested in astronomy, then head over to our Deep Space playlist, and if you did enjoyed this video, then like this video, and share this video to your friends, and stay updated with our stuffs.